Details about the further remaining losses. In that first one, elastic, deformation loss. This loss is developed due to the elastic property of concrete. It is calculated using this formula M into Fc, where M is equal to modular ratio it is the ratio of Young's modulus of steel divided by Young's modulus of concrete, and Fc is equal to pre-stress. Simply multiplying of both these values, we can find out the elastic deformation loss. Next is shrinkage loss. Shrinkage loss is developed due to the shrinkage property of a concrete. Loss is calculated using this formula: shrinkage strain multiplied by Young's modulus. This is the basic definition of a stress: strain multiplied by Young's modulus. So loss is calculated as epsilon sh multiplied by Es. Shrinkage strain is calculated as, for pre-tensioning epsilon sh is equal to (3 into 10 raised to minus 4) for post-tensioning epsilon sh have to calculate using this formula: 2 into 10 raised to minus 4 divided by log of base 10 into t plus 2, where t is equal to age of concrete in days. Next is creep loss. This loss is developed due to the creep property of a concrete. We can find out this loss using two approaches. Approach 1, when creep coefficient is given, you have to use this formula: phi into m into Fc, where phi is equal to creep coefficient phi is equal to creep coefficient. M is modular ratio. Fc is again pre-stress. Creep coefficient depends on age of concrete. For 7 days, creep coefficient is 2.2. For 28 days, creep coefficient is equal to 1.6. For 1 year age of concrete, creep coefficient is 1.1. Then how to find out the creep loss using approach 2? When creep strain is given, you can use this formula. Creep strain multiplied by Young's modulus multiplied by Fc. Symbolic form is loss is equal to epsilon creep multiplied by Es multiplied by Fc. Using this formula, we can find out the creep loss when creep strain is given. When creep coefficient is given, you have to use this formula. When creep strain is given, you have to use this formula for calculation of creep loss. Finally, the relaxation loss. Relaxation loss, it is also called creep in steel loss. Generally, this loss is in between 2 to 8% of initial pre-stress.